This is day 19 of Advent of Cyber 2023, and this challenge is called CrypTOYminers Sing Volala-lala-la-latility. The elves are hard at work inside Santa's Security Operations Center, looking into more information about the insider threat. While analyzing the network traffic, Log McBlue discovers some suspicious traffic coming from one of the Linux database servers. Quick to act, Forensic McBlue creates a memory dump of the Linux server along with the Linux profile in order to start the investigation. So, the learning objectives for this challenge are to understand what memory forensics is and how to use it in a digital forensics investigation, understand what volatile data and memory dumps are, learn about volatility and how it can be used to analyze a memory dump, and learn about volatility profiles. So, what is memory forensics? Memory forensics, also known as volatile memory analysis or RAM forensics, is a branch of digital forensics. It involves the examination and analysis of a computer's volatile memory to uncover digital evidence and artifacts related to computer security incidents, subcrimes, and other forensic investigations. This differs from hard drive forensics, where all files on the disk can be recovered and then studied. Memory forensics focuses on the programs that were running when the memory dump was created. This type of data is volatile because it will be deleted when the computer is turned off. So, what is volatile data? In computer forensics, volatile data refers to information that is temporarily stored in the computer's RAM and can easily be lost or altered when the computer is powered off or restarted. Volatile data is crucial for digital investigators because it provides a snapshot of the computer's state at the time of an incident. Any incident responder should be aware of what volatile data is. The reason is that when looking into a device that has been compromised, an initial reaction might be to turn off the device to contain the threat. Some examples of volatile data are running processes, network connections, and RAM contents. Volatile data is not written to disk and is constantly changing in memory. The issue here is that any malware will be running in memory, meaning that any network connections and running processes that spawn from the malware will be lost. Powering down the device means valuable evidence will be destroyed. What is a memory dump? A memory dump is a snapshot of memory that has been captured to perform memory analysis. It will contain data relating to running processes captured when the memory dump was created. Benefits of memory forensics. Memory forensics offers valuable benefits in digital investigations by capturing real-time data from a computer's volatile memory. It provides rapid insight into ongoing activities, detects stealthy threats, captures volatile data like passwords, and allows investigators to understand user actions and system states during incidents, all without altering the target system. In other words, memory forensics helps confirm malicious actors' activities by analyzing a computer system's volatile memory to uncover evidence of unauthorized or malicious actions. It provides crucial insights into the attacker's tactics, techniques, and potential indicators of compromise. Another thing to keep in mind is that capturing a hard disk image of a device can be time-consuming. Then, you have to consider the problem of transferring the image, which could be hundreds of gigabytes in size. And that's before you even consider how long the analysis will take the incident response team. This is where memory analysis can really help the IR team. Capturing a memory dump from any device will be much faster and smaller. Suppose we prioritize RAM over a hard disk image. In that case, the IR team can already start analyzing the memory dump for IACs while beginning the process of capturing an image of the hard drive. What are processes? A process is an independent, self-contained unit of execution within an operating system that consists of its own programmed code, data, memory space, and system resources. Imagine your computer as a busy chef in the kitchen. The chef can cook multiple dishes simultaneously, but to keep things organized, they use separate cooking stations for different tasks. Each cooking station has its own ingredients, pots, and pans. These cooking stations represent what we call processes in a computer. This is crucial in memory forensics because knowing the process that we are running during the capture of the memory dump will tell us what programs are also running at the time. We can categorize processes into two distinct groups. User processes. These are processes a user has started. They typically involve applications and software users interact with. Example is Firefox. This is a web browser that we can use to surf the web. And then background processes. These are processes that operate without direct user interaction. They often perform tasks that are essential for the system's operation or for providing services to user processes. An example would be an automated backup. Backup software often runs in the background, periodically backing up data to ensure its safety and recoverability. So, connecting to the machine. Before moving forward, review the questions in the connection card shown below. So, to connect to a machine, we need to start the virtual machine, and if you want, you can connect via SSH or RDP, but there's also split screen if you want to do that. Volatility. Volatility is a command line tool that lets digital forensics and incident response teams analyze a memory dump in order to perform memory analysis. Volatility is written in Python and can analyze snapshots taken from Linux, macOS, Windows. Volatility has a wide range of use cases, including the following: listing any active and closed network connections, listing a device's running processes at the time of capture, listing possible command line history values, extracting possible malicious processes for further analysis, and the list keeps on going. So for this task, we'll examine the memory dump of a Linux device, and for our convenience, volatility is already on the VM, and if we type vol.py-h, we'll be able to confirm if it's on or not. If you want to know how volatility can be installed and all of the other benefits, there's a volatility room on TryHackMe. At the time of writing, there are two versions, Volatility 2 in Python 2 and Volatility 3 in Python 3. There are different use cases for each version, and depending on this, you might choose either one over the other. For example, Volatility 2 has been around longer, so in some cases it has modules and plugins that haven't been adapted to Volatility 3 yet, and for the purposes of this task, we're using Volatility 2. So volatility profiles. Profiles are crucial for correctly interpreting the memory dump from a target system. A profile in volatility defines the operating system's architecture, version, and various memory specific to the target system. Using the appropriate profile is crucial because different operating systems and versions have different memory layouts and data structures. Volatility comes with many profiles for Windows operating system, and we can verify using vol.py-info. Did you notice that there aren't any Linux profiles listed? Profiles for Linux have to be manually created from the same device the memory dump is from. Here are some of the reasons why. Linux is not a single monolithic operating system, but rather a diverse ecosystem with many distributions and configurations. Each distribution may have different kernel versions, configurations, and memory layouts. The variability makes it challenging to create a one-size-fits-all profile for Linux. Unlike Windows, which has a more standardized memory structure and system APIs, Linux kernels can vary significantly across different distributions and versions. This lack of standardization makes it difficult to create generic Linux profiles. Linux is open source, meaning its source code is readily available for inspection and modification. This leads to greater flexibility and customization, but also results in more variability in memory structures. So creating profiles is out of the scope of the room. So for our convenience, a profile is already made on the desktop directory. So desktop evidence will have the Linux memory dump and then the profile. So to use the profile, we have to copy it where volatility stores the various profiles for Linux. So if we go to the virtual machine, open up the terminal. So in here we need to go cd desktop and then evidence. So in this directory we've got the profile and the Linux memory. Then we need to copy the zip file to the location in volatility where it has its profiles. So copy Ubuntu profile, and it's going to the volatility Python package, and it's storing in plugins overlays Linux. So press enter on that, and now it's copied into there. And if we do vol.py-info and then grep Ubuntu, it would help if I could spell it correctly. So VOL, we can see that our Ubuntu profile is now in there. Okay, memory analysis. The file linux.mem contains the memory dump of the server we're going to analyze. The file is located in our home directory. For volatility to begin the analysis, we have to specify the file with the -f flag and the profile with the --profile flag. We can use the -h flag to look at all the different plugins we can use with our analysis. So we can copy this here and put into here. So if we look at the command, volatility on the file linux.mem with the profile Linux Ubuntu. So press enter on that, and it's given us, I assume, a bunch of commands which we can use on this memory dump. So let's go back and take a look here. Alright, those are all the different plugins that we can use. So volatility plugins, history file. The history file is a good place to start because it allows us to see whether there are any commands executed by a malicious actor while they were on the system. To examine the history file for any such commands, we can use the Linux bash plugin. The command will take a little less than a minute to finish executing. So if we go back with our command, get rid of the -h and use linux_bash. So we can see here a bunch of commands that were ran. So it starts off with cloning a GitHub repository and enters the source of this repository. It compiles it. Seems like they tried to change the bash history. They entered the home directory, switched to root, though then we can't see that, so they did something that they exited. They are using MySQL, and they're using the user root and this password, and then they're connecting to this IP address /toyminer. They're curling to this and saving the output as miner, and then they execute miner. Okay, so let's continue. So when performing a cross-reference check with the ELF analyst who was using the server, we identify the following suspicious commands. So the MySQL command was used by the ELF analyst, but the cat bash history command was not. This means the malicious actors most likely saw the MySQL command and had access to the database. There is a lot of sensitive information about the merger and the pipelines that the malicious actor could have gained access to. We also identified the curl command, which the alpha analyst confirms they didn't use themselves. This tells us that the malicious actor used curl to download the toy miner file and saved it using the -o parameter as a file named miner. We can also see that the malicious actor executed the miner file with the command. So now that we understand what the malicious actors executed, we can look into the system's running processes. So running processes, we now use a plugin Linux PS list. So go back to here, Linux PS list. And we've now got a list of processes, and we can see down here, miner was ran. I guess before we go on too far, let's take a look at what the questions are for this. So what is the exposed password that we find from the bash history output? Let's go back to the previous command. Okay, so the password is found here. So we can now go submit that. What is the process ID of the miner process? So that is right here, 10280. 10280. What is the MD5 hash of the miner process? It's going to be one of these, let's assume. What is the MD5 hash of the miner process? Okay, I guess we'll carry on now from where we were. As you can see, the plugin doesn't just list each process name, it also has the process ID and the parent process ID. This helps determine what is often referred to as parent-child relationship between processes. There are only 2 anomalies that we can quickly identify. The alpha analyst confirmed they didn't execute the miner process. Based on the program name, our initial assumption is that we may be dealing with a crypto miner. A crypto miner, short for cryptocurrency miner, is a computer program or hardware device used to mine cryptocurrencies. Cryptocurrencies are digital or virtual currencies that use cryptographic techniques to secure and verify transactions on a decentralized network called a blockchain. An insider threat could be trying to use our Linux server to mine cryptocurrencies and make some extra elf bucks. The MySQL server appears to be benign, but this is misleading. The real process for MySQL is called MySQLD, as listed above. The alpha analysts confirmed that they didn't execute this. Given that the PID of this process is different from the PPID of the miner process, this process did not spawn from the miner directly. So if we go back here, MySQLD, okay, we would like to know more about these processes. A good way to do this is by examining the binary of each process. We can do this via process extraction. So a good way to understand what a process is doing by extracting the binary of the process. This will help us analyze its behavior using malware analysis. We'll also want to extract the binary of the process as a form of evidence preservation. To extract the binary of the process for examination, we can utilize the Linux procdump plugin. We just need to create a directory to indicate where we would like the extracted process to go with the mkdir extracted command. Then we use the -d to tell volatility where to place it. So we will do that now. So mkdir make directory extracted, and then the command procdump -d extracted -p 10280. Okay, so we now have the file, so ls extracted, and we wanted the MD5, so pretty sure we can just do MD5 extracted miner like that, or is it MD5 sum? There we go. So we can now copy this and put it in the question where it asks what the MD5 sum is, hash of it. So now we want to do the same thing for the MySQL server process. So that MySQL server, that was 10291. So we'll do the exact same thing before, where we extracted it, 10291. Run that. We've now got the file, then same thing again, MD5 sum extracted and MySQL server. So we can now grab the MD5 hash of this and put that in the question here. Okay, so use the command this. What is the suspicious URL? Fully define the URL using cyberchef. So we'll copy this command. The strings command is used for retrieving text that's within an executable. So strings extracted, and then we need to put in the name. So miner.10 to 80 and search for URLs. So this one here looks like it. I don't want to actually go to it. So McGreedy secret tc2. So McGreedy secret c2.thm. So we'll copy that and put it here. Actually, let's take a look. Is that the one we want? Okay, so it's in a different format. So it wants us to use the cyberchef. So what we'll do, go to cyberchef. We'll put this here and we will search for Fang, the Fang URL, put that there, and we now got this. So we'll copy that and paste that here. After reading the Elfie file, what location is the MySQL Server process dropped in on the file system? Okay, so we'll go back to where we were before. So it got extracted, we did the MD5 sum on it. Okay, now file extraction. As stated above, we want to look at any cron files that may have been placed by the malicious actor or crypto miner. This can help us identify if there were any persistence mechanisms at play. For example, the MySQL Server process we found before part of a persistent mechanism. But how can we enumerate files on the server? We can use the Linux enumerate files plugin to help us with that. So we will go back to here, start our vol command. We will go back and change the plugin being used to Linux enumerate _ files, and then grep -i cron. It's basically searching for anything that's cron. So that is now finished running, and we see there's cron tab for Elfie. Let's go back here. So we quickly identify the cron tab located here. We speak to the elf analyst, who confirms they didn't have any cron jobs set up on this server. We can now extract the file by selecting the inode value, the hex-like value located to the left of the file name, using the -o option to name a file during output and place it inside our previously created extracted directory. So I'll just copy all of this, and we can put that here, and we'll now run that. Okay, so that's now finished running. And what was the last question? What location is the MySQL Server process dropped? So I assume we can just do cat extracted, then cron, or what was it called? Elfie. And MySQL Server was dropped at this directory right here. So we can now copy that and submit. So that is day 19 of Advent of Cyber 2023. If you like this video, make sure to like and subscribe so you can watch me complete the rest of these challenges.